Hi, I'm volcanologist Dr. Janine Kripner, and this is my guest.
I'm Steve Malone. I'm a professor emeritus at the University of Washington in Seattle, and I was a seismologist that ended up sort of being on the front lines during the 1980 Mount St. Helens sequence.
Thank you so much for joining me for this special series for the 40th anniversary of the eruption of Mount St. Helens. You were one of the very first people to see the signs of that Mount St. Helens was coming back to life. What was that like, seeing those first signals?
Well, thinking back, actually, at the time, I was sitting in my office working on something totally different. And our seismic analyst dashed into the room and said, "There's a big event coming in on the Mount St. Helens station. Maybe it's right there." So I ran down to our recording room, which had these old-fashioned paper drum recorders called helicorders and developers where the film is developed, and stood there looking at this going, yeah, that's a pretty good-sized earthquake. Well, it took us a little while to actually figure out exactly how big and where, because at that time we didn't have computers that were helping us out hardly at all. We would read the records by hand using rulers and pencils and punch up type, those old key punch cards, carry them up, put them through a card reader, run a program that would locate the earthquake. And, oh, yeah, this is right at Mount St. Helens. It looks like probably about a magnitude 4 to 4.2. Pretty significant. Well, at that time we thought, okay, maybe that's it. Or it'll be a little aftershock sequence, which is not unusual for earthquakes of that size, to have a few more earthquakes take place and die away. Just so happened we had some portable recorders available to us. And a colleague and I decided that we would take them down to the mountain the next day and install them, just in case. And indeed, just in case was the result.
Absolutely. Wow, I can only imagine what that would have been like. What was it like for you going through the lead up to the eruption, realizing this is the volcano?
Yeah, and it was a real roller coaster of emotions, from certainly excitement early on. Wow, this is happening right in our backyard. The earthquakes built up over that first week very rapidly and became so fast and furious that our station right on the mountain, the records were totally saturated. You couldn't pick one earthquake from another. And we very quickly installed a bunch of other stations, some of them local recorded, some telemetered, but we were still just recording on film that we could use. It so happened, though, we had one of the very first digitally triggered computer recording systems that we had just started a few weeks before. However, we had no software to do the analysis. So it was like write-only memory. The data went in, but we really couldn't use it to do anything at first. So it was frustrating. So the excitement, the frustration, the adding more stations, and then as soon as it got out to the news media that something was really happening, the press showed up at the labs, and it was just chaotic, crazy time.
I bet it was. How much work was going into trying to look at the signals and understand what was going on? Did you have a large team of people around you who were doing the seismology analysis?
Well, we started off with not very many at all. There was, I guess, sort of 3 seismology professors, a few grad students, a technician or 2, an analyst. But very quickly, we sort of got volunteers to come in, people from other parts of the program there, and even, well, for example, the fellow named Dave Johnston, who plays an important role in the whole story. He happened to be in town and he heard about this, and he shows up in the lab, and I say, and I knew him from before, I say, "David, can you help out?" So I had him counting records and looking at things, and we were discussing back and forth what was going on. And after the first steam explosion, which took place a week later, I was inundated by things like TV stations to fly down there with them in the helicopter to be the expert Well, I'm a seismologist. I'm not a volcano expert. David was in the lab. So I said, David, you do it. And he was very happy to. And so he went off and did interviews and saw things up close after that first. And I saw him from time to time over the ensuing couple of months. And it was this, like I said, this roller coaster. Luckily, most of the press focus turned out to be down with the USGS personnel in Vancouver at the Forest Service headquarters. And so we felt a little bit of relief in our labs. But we were in constant contact with those guys, telling them that this many earthquake has occurred, it's changing this much. Now we see volcanic tremor. What do you see? Back and forth, back and forth. After 2 months, not a lot of sleep. It was then very tiring too. And I wouldn't say boring. It never got boring, but you got sort of used to this constant being up and on and worried. And so May 18 was out of the blue. The big eruption came with no changes in the seismic activity that we could see either at the time or even in retrospect, going back and looking at recorded data. There was just earthquakes banging away, and finally one was big enough or different enough, or finally it caused the whole thing to start.
That must have been an incredibly difficult time for all of you, especially with the loss of your friend. Looking back, 40 years now has passed, and the technology in seismology and the understanding of seismology has progressed incredibly. How has it been seeing all of this new technology, and what are some of the most amazing things to you in the progression of seismology?
Yeah, of course, over 40 years, the technology, like you say, is really very different in many respects. Some of them are similar, though, and that is that you want stations close to the volcano, seismic stations. You want them distributed around the volcano at different distances, which we tried to do then. And then you need to record it and process the data quickly at our end. The difference being, of course, that now that's mostly automated. The computers do an awful lot of what we had to do by hand back then. And so the results are immediately available to you. Plus, there are other types of technology that is used by the geodesists for looking at deformation, gas chemistry, petrology, all sorts of other types of geophysics can be brought to bear on the problem. I'm a seismologist, and so I still think that's the most important. But even there, the instruments are far better. They have wide dynamic range, so they can record on scale from the tiniest event to the biggest over a broad frequency range. You can see very rapid shaking as well as slow shaking. And this all leads us to improve our models of what's going on with the volcano. And ultimately, that can lead to better forecasting of what's going to happen.
The event that happened was, as you said, a surprise. The size of it, when it happened exactly. How do you think it would have been different if you had today's technology back in 1980?
Yeah, that's that type of Monday morning quarterbacking is really hard to do. You can say, oh, we would have done a much better job. I don't know necessarily that we would have, just because of the technology. That's important. But I think probably the experience that's taken place both there as well as many other volcanoes in the last 40 years is probably more important. You've learned better the range of types of things that can take place. And of course, today, if we saw this type of deformation, bulge, shallow events, asymmetrical, that would have very definitely been a big clue that something to the north side was going to happen, and it could be much bigger than what had been seen in the geologic record before. Of course, that is what happened in this case, and that taught the science a lot, just that process.
There was definitely an eruption that spurred so much change in volcanology, and it blows my mind the incredible science that was done at the time with the technology and the limited experience in such a young field. It was just an incredible job. So thank you so much for joining me. I appreciate your time.
Well, it was enjoyable. Thank you.